Okay, so download this tool called Visual Studio Code. Okay, this you can just Google. Again, it comes from, it's published by Microsoft. So it's safe to, as long as you go to Microsoft, to download this. This thing runs on Windows, Macintosh, Linux, and even, I think, Chromebooks. You know what Chromebooks are, right? So basically, this thing runs everywhere. That allows you to do all kinds of programming, actually. So once you download this, and when you start it up, it will look something like this. If this is a start, close everything. Close everything. Everything. Okay. So this is a start window. It really doesn't have anything yet. It's just showing you, what you can do with this tool. You can start playing with it, create new files or open a folder and things like that. And and when you are in this tool, you can actually open up a terminal. And this is actually, this allows you to get onto the, the computer command line. Okay, this you can do this on Windows, on, again, Linux, on all these computers. I'm not sure about Chromebook stuff, because I don't know if Chromebooks have a command line or not. But what you can do here is you can run command line like git, right? Git again Git is probably more complicated. I don't know. We don't have time to get into here, but that's what this Git repository thing is. Okay, so I'm going to close this one, and I have a terminal, Microsoft terminal, installed here. So, and also I have, let me go into here. Python. This is just folders on my computer. Okay, ACSL. I've already created a couple of files in here, so I'm just going to show you what I have. And once you do Git and stuff, this is what a Git repository is. .git. It's a folder. Okay, it has a bunch of files inside it. The purpose of Git is for me to keep track of my changes. If I make make changes to my files, and then I check into the Git repository, Git will remember what changes I made. And it allows me to do diffs, right? So that I can find out what changes I made between today and like 30 days ago, let's say, right? I can see all the changes between today and yesterday, or 30 days ago, and all that. So that is very helpful when you write code, write a large program, and you have errors, and you just couldn't figure out what you did, right, to break your stuff. That helps. So what I'm going to do is, okay, So this is what we have. Let me open up that slide. Okay, this is the last lecturing stuff that we're going to do for our class. So what we have left, let me do something else here. ACSL Junior. So this is what we have, right? We have done so far. We have gone through all these, right? So contest 1, there's computer number system, recursive function. What does this program do, right? That's always going to be there. And contest 2, prefix, infix, postfix, bit string. And then 3, Boolean algebra, and 4, graph theory and digital electronics. Right. So we've gone through those. Now what we have left are programming problems. Right. Programming problems, also there are samples of that. So this is what we have left, right? Programming problems. And the format of programming problems is that you have 72 hours. Okay, that's 3 days, right? 3 whole days to solve the problem. So I want to tell you it should be easy, right? Even if you don't know anything about Python and you just, what is it so hot? That you're just going to learn. Okay, we'll get started. You're just to learn, prior, just, when this thing starts, right? So you can go into HackerRank, right, and find out what the problem is, and try to solve it in 3 days. But of course, the less time you spend on it to solve the problem, the higher your rank would be, right? The more, the higher your score would be. So there are these again 4 sets of problems, right? Number transformation and string stats. ABCs, it's just basics, right? And duplicates. So we're going to go through these sample problems and just, to learn the categories of problems that you will encounter in these contests. So as you can see that this, I've already opened them up. So what I'm going to do is, here. This is the problem for number transformation. It's actually, I don't know, I find these problems really not very, very interesting, to be honest, but that's what we got, right? So you need to read the problem description carefully, right? So you have, so basically you're going to create a function that transforms numbers, right? Whatever numbers you're given. So the parameters you will have n, p, and b, right? N is a positive integer. And also, what it says down somewhere, I forgot where, it's probably, let me scroll down some more. Okay, it is, what I want to say is that don't worry about, invalid inputs. Right? That's not the purpose of the contest. So just take the parameters, just assume that they're always going to be okay. When you have inputs, you're always going to get inputs. Just assume that, okay. So you got three numbers, right? N, C, D. A positive integer is given to you, and then another positive integer, and another one, right? Three integers. So you're going to transform P, N, sorry, right? But it's looking at the position P, right? The P digit of N from the right, from the right end count to P position, right? If that digit is 0 to 4, then you add B to it, to that digit, and then replace that P digit in N, okay, by the unit digit of the sum. Then replace all the digits to the right of P with 0. Okay. And then if the digit is 5 to 9, then you do something else, right? Something different. What you do is subtract B from that digit, right? And replace that P digit with the leftmost digit of the result, of the absolute value of the result, right? The difference from this subtraction. Then replace all digits to the right of P digit by 0. Okay. And so here are two examples, right? So when we look at this problem, right? This is the code that I have come up with. I just here's the whole file, right? The Python file. Okay, a little bit about Python programming, syntax, basic. This 3-quote thing between this 3-quote, single quote or double quote, doesn't matter, both work. Between that and this whole section is called the document. Okay, you can put documents anywhere in this whole file. What the document do is literally just document, right? Document what this program is supposed to do, nothing else. Right? The document here is basically a copy of that problem, right, from the PDF file. Now, that is from line 1, right, all the way to 34. And now here, def is a function definition. What that does is it creates a function. The function's name is transform. Okay, it takes 3 parameters, right, as that problem description requires us to do, asks us to do, right? So it takes 3 numbers, right? And then if you look at this section of code, right, you'll see that lines between after 36, right, between 37 and 45, they're indented, right? They have the exact indentation. This is the peculiarity with Python. Okay? Python uses indentation as a marker for code blocks. Right? It means that these lines make up a block of code that, in this case, makes up this function. Right? This is the body of this function. Okay, so after this, right, this is actually, so this defines the function, and now here we're actually calling that function, right? Calling that function with these numbers, right, given like this one, this is an example, right? So n equals that, p equals 2, b equals 8. So I'm going to call that function with these three numbers. Yeah. Sure. So this is the whole program. That's all. Oh, up. Or I can just show you the PDF file, right? That's what this is. Oh. What did I do? Make it slightly smaller, right? So I'm going to show you the code here and the problem here, right? So this is the problem. You don't have to write notes on this one. This is actually on their from their wiki page. So if you go to the website, right, and study materials, and then open up the junior division, and these are the problems, right? Programming problem 1, 2, 3, 4. So I just opened those up. So this is the problem, right? You'll be given, and this is the kind of code you're gonna produce, right? So how many? Raise your hand if you have done Python programming. 1, 2, 3, 4. Okay, half. So, like I say, you can basically just Google. Where did that go? Oh, yeah, I'll just use this. Python program, right? So really, I'm thinking the more important thing is probably to think the problem through, right? To me, I think programming language is not as important as actually understand the problem and think about an algorithm, right? How you do this problem. And here's what I came up, right, with this particular problem, right? So it is giving you a number, right? And then it is asking you to replace digits inside that number. So what I'm going to do, I think, is I'm going to treat this number as a string, right? Because if I treat it as a string, then I can chop it up, right, into however many digits in there, right? And then I'm going to just go find that position and do my, addition, subtraction, or whatever. Right. So based on that thought, this is what the code I come up with. Right. I'm going to turn that n number, right, into a string. That's what this first function call means. str run n is basically turning that variable, that number into a string. So if I can show you in the terminal here, I open up Python, run Python 3, right? If I give n a number, right? 1, 2, 3, 4, 5, 6, 7. Right. So if I type n, it'll just give me that, see, that number back, right? But if I do, who can tell me what I'll get? A string, exactly. But a string will have those digits in there, right? But the way that Python tell you that it's a string is that it quotes it, right? Gives you a single quote. So that is a string. right? So I turned that number into a string. And now you can see what I did next, right? I throw that string into a function called list. Okay, let's see what that does. List. Who can tell me what that does? Okay, a list of all the digits in that string, right? See, so this is what I did here, right? So with this two function call, I turned that number into a list of digits. Now I can go, if I'm given p as 3, for example, then I'm going to count 1, 2, 3 from the right, right? And I'm going to work on this one. Does that make sense? Question?
No.
Okay, so you can see what my code does next, right? So what did I do next? Next, I'm going to take this, now this nx is a variable, right? It's a variable that contains that list. The list contains all the digits in the number n, right? And now I'm going to do count from the right, right? Because p is a positive integer as specified by the problem. When you say minus p, it means in Python to count from the right end of that list, right? So we're going to get from the right p digit in n from the right. Right? This is the this pound also. If I do a pound in this line, that means from the pound to the end of this line are comments. And this basically is telling me or telling you what this line does. Right? So I'm going to take the p digit in n from the right. And again, now I'm converting it back into integer and put it into np, this variable, right? Now next what I'm doing is if that digit is between 0 and 4, right? If it's between 0 and 4, then I'm going to add b to it and then get the unit digit, the last digit from that result, right? And then turning it back into a string and replace it in there, right? In that list. If it's not between 0 and 4, then I'm going to, well, the problem says 5 and 9. So is one digit, you can only have 0, 4. 0, 4 is one part and 5, 9 is another range, right? You can't be anything else. So I can just safely say else here. So if it's not between 0 and 4, then I'm going to do the subtract, right? Subtract b from that digit and then get its absolute value. ABS means the absolute value of this difference, right? And then again, turning it back into a string and then turning it back into a list. Okay, so in Python or in any language, actually, you can do this function call and then pass the result of that function call into another function call into another function call. Right? So you could do this type of thing. So what I can do is I can show you, right? For example, this list, right? So if let's say p is 3, right? Then I'm going to do if I assign this to nx, right, then nx minus 3 is 5, right? It comes from the right third position, right? So that's between 5 and 9, right? So now what I do is do this, right? So if I show you this, you can see what the result would be. I don't have D in. That's going to error, right? So I'm going to say this will be NP, right? NP equals integer of that, right? That's what NP is, right? From line 38 there. So I'm going to create an NP, and let's say D is, let's give it an 8, right? So now we can do this. Right? How do we get that? So NP minus D is minus 3, right? Let's give D a bigger number. How about that? So now it's going to change, right? It's going to be minus 883. And so the function call is ABS, right? That's the absolute value. It's just going to be 883, right? And the next one is I'm going to turn that into a string. It's just going to be a string of 883. And now the next function call is turning that back into a list, right? It's going to be 8, 8, and 3. And the leftmost digit is what we are interested in. That's the one that we want. So that is position 0, right? It's always going to be 0, the leftmost. That's what this line of code is, right? So it's going to take whatever number, NP minus D, and then get its absolute value, and then eventually find the leftmost digit. Any question about that? If anything is confusing, just let me know. Okay. And you can actually do this separately, right? You can do it, one function call at a time. You can do an x equals to NP minus D, and then, y equals to, one step at a time, right? You can do that. But this is basically a compressed way of just putting all the function calls together and find the leftmost digit of that, the absolute value of the difference based on the problem description, right? Subtract D from it, from the P position in N. Replace that digit by the leftmost digit of the absolute value of the difference. Right? It's basically what that one sentence turned into that one line of code. Right? So this is what we're going to find those digits and replace them in this list, right? Now, it's still going to be a list of digits, right? And now, and the other thing we need to do is to, it says, then replace all the digits to the right of P by 0, right? It's the same in both cases. So that's why after this replacement, then we're going to find from minus p, add one position, right, to the right, right, all the way to 0, right. 1 is the step, right. So we're going to do if p is 4, for example, then we're going to do minus 4 plus 1 is minus 3, right? 3, 2, 1. 0 would not be there, right? Because counting from the right is 1, 2, 1, 2, 3, or minus 1, minus 2, minus 3. So we're going to replace all those with 0. Right? So these two lines means to, if you got a list now, like we have here, NX is a list, right? So if P is minus 3, for example, P is 3, right? Then you count from the right 3, and you're going to work on this digit, and you're going to make these 0, right? So that's what we did there. And eventually we're just going to print it out, right? It doesn't really need us to do anything but print out the result. So this is basically joining the list back into a string and then print it out, right? So if we do, if I do this, dot join, right? NX. It means putting all those single digits, right, back into one string. Right. So if I say, because you can actually put anything in here, you can join them with anything. So you can do that. And you could also do basically anything. ABC, for example. Right. So that's basically using a string to join other stuff, join a list, right, into a longer string, into a single string. Okay, that's what that does. So now if we want to print it out, print basically it's going to just print out the string as a value, right? So it won't do the quote thing, right? So which would make it look like an integer as the output, right? So that's what this whole program is, right? And then these two are samples in the problem description, right? And then these are the data that it provided in that problem. Right. So, and it's got those sample inputs and then also the test inputs, test outputs, right? And so, and here, I'm not going to do inputs. Right? I'm just going to put those data in here and then call that function with each and every one of these sets, right? So you can see this, yes. So it's going to take XD. XD is going to be each one of this, right? Each row in here in this array, right? So it's going to take this row, and this star thing is basically to break that. That is still a list, right? So it's going to break that list into 3 individual values and pass it to that function. So this makes this code simpler, right? Or you can actually do is right transform blah 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 blah, right? Repeat 10 times, and it's the same result. So let's see what that does, right? So here are those files, Python 3 C1. Right? This is that program. Right? These are the output. Right? So that's all you need to do in this type of problem. Does that make sense? Some sense? Clear as mud? Again, I want to emphasize that these functions are probably important for you to remember. At least remember that they exist. Like, know that they exist, so that you can, know to look up. Because if you, I don't use Python. I forget these things, but I know that they exist, so I can go Google, and I can Google, say, Python absolute value, right? I want to find out what function finds the absolute value. Okay. So you, with the also, Python are organized in packages. Right. So their basic Python syntaxes, right? So like this creates a list, right, of these things, and put it into value, put it into the variable a, right? And this also is a list, and put it into value a. And then, for example, a list has function length, right? Or length can work on list, right? So, like in here, if I do Python 3, right? Right, if I do this, right, I can do length, for example, find out how many items are in that list, right? Length also works on strings, right? So if I say a, right, it tells me how long that string is. So these simple functions you would need to know that they exist, right? And also, as I say, Python is organized in packages, right? So when you need to use a package, for example, math, right? You would do that. No, not math. It's math. Yeah. So, and once you import a package, you can do help and find out what's in that package. Okay. It tells you, like, It's A cosine A, hyperbolic cosine, A sine, hyperbolic A sine. So you got all these functions in there. Right? So you have ceiling of the integer of a number, right? I don't even know what some of these are. So you can find out what functions are in this package, right? Math. You can just page through this. Right? This is actually a simple way to learn things, right? To learn about Python, for example, you can find out what's in here, and now you know what's there, right? You can actually just run those functions right here. Right? And for example, these are the data that's in there. But how you use that is, for example, math.pi, right? That gives you the value of pi, right? And E.
Wait, so you have to add math?
Right. That is a package that I imported here, right, with this statement. Right, you have to, if it's inside a package, Python has the core functions, right? Like the length function is a core function, meaning that it's there, right? Once you're in Python, it's there. But other functions like math and string array, there are certain functions that are built into separate packages that you need to import, like math, right? Math, like these. So once you import math, then you can find out what's inside the package here, right? And yeah, and then when you need to run a certain function, right? Then you just say math.atin, for example. Right? Then you call this function and give it a number and what is that slash? Oh, you can try it and find out, right? Oh, and remember that some of these are measured in radians, right? So, for example, if you do this, if you have an angle like 90 degrees, then you have to convert that into radians and then call the function, right? So that's math. You can find out like all the basic Python stuff in python.org. That is the official website for Python, for this language, right? So anything that you want to find out about the language itself, you will find them here, right? And obviously you want to probably just go read the documentation, right? So that's what that is. Here you can actually, again, it's probably a little more complicated than you expect, but right, you have to go with different versions, right? So you can find out the latest, you can find out what your version is once you get into Python, for example, you can say version, I think. No. Here, when you go into Python, it tells you that, right, it's 3.8.0, right? So you can go read the corresponding version of the documentation, right? And so tutorial is the basic stuff, right? And library reference gives you all those packages. Right, there are actually thousands and thousands of packages. So what we are going to need really are just the real basics. Okay, built-in functions, built-in the built-in stuff, right? And then the text processing is what you may want to find out, like string, right? I don't think you need much else, but these basic types you want to, especially like number, numeric type, Boolean, sequence, right? List, like what we just did, and string. Binary sequence is a little bit confusing, I think. You could probably ignore that in the context of ACSL. Just the basic, the real basic stuff: string, list, number, dict, set. Okay, these are the the more basic stuff that I think you probably will encounter in the ACSL context. And then text processing, really, you don't need to go beyond string. Right? Anything else is more advanced than you would need. Okay, I think we'll take a break here. Ask any questions, okay, if you guys have any questions. Right, so that's my recommendation for you guys to, if you are interested in doing any kind of programming at all, right, this is a good tool to learn, to use, and just to explore. Okay, so the next problem, okay, the next problem is this, right? So this problem is string stats, right? String statistics. So the problem says you're given a sentence, right? A sentence like this, right? The quick brown fox named Roxanne jumped over Bruno, a lazy dog. So that whole thing is a sentence, right? Now it's asking you basically again to write a function to, given that sentence, provide these results, 1, 2, 3, 4, 5, right? So it asks you for the number of different letters, right? This would be a number from 1 to 26, right? Because there are 26 letters. Basically, that statement is not very clear, but I think it implies stuff like it wants the count of letters only, right? No space, not the comma, not the period, right? So you're gonna throw those things away. And also for the number of different letters, it's case insensitive, right? As it says, it's from 0 to 26. So if you count both uppercase, lowercase differently, then you'll probably come up with more than 26, right? You can't come up with more than 26. You guys have something interesting for share with us? Okay. So, and the number of vowels, right? Vowels are these letters. So it gives you the conditions and asks you for the result. The number of uppercase letters, right? So there's a certain number of uppercase letters in there. Number of times most frequent letter appears. There's no distinction between lowercase or uppercase. Okay? So you got whatever number of letters in there, and what is the most frequent one, right? And the longest word in that sentence. All right. So how do we do this? Anybody want to share some thoughts? Well, it's the function or not doesn't really matter, right? A function means that you can use that, you can call that function to process different strings, different sentences, right? So you don't have to repeat that whole whatever code you have. Oh, yeah. Yeah.
Yeah, right.
So now the question is, in that function, what do you do, right? How do you count the number of letters? And how do you count vowels, right? And how do you count uppercase? And how do you do these different counts, right? So basically, there are certain things that can count, right? For example, different letters. Different letters, it's case insensitive, right? So what that means is that when you count that, you want to convert the letter. Oh, well, one thing is that you obviously need to go through this whole sentence, whatever you're given, right? One letter at a time, right? So you can, deal with each letter. So you would have a loop that goes through the string, right? One letter at a time. How do you do that? String could be accessed by the position, right? Each letter has a position. So it's 0 to at the beginning of the letter of the string, 0, 1, 2, 3, 4, 5, 6, 7, 8, right? Well, space is not counted in probably anywhere, but space and other things are what breaks words, right? So those are important markers for words. So you have to know where to begin and where to end of the word, right? So I'm going to make this your homework. You can work on it right now. While we're discussing this, you can jot down your ideas, and then next time I want you guys to give. How's that? This is basically very much like the contest, right? You got 70 hours to finish this, but now we can have a discussion of how we're going to do this, right? So obviously you're going to have a loop to go through the string, right? And then you're going to look at each letter one at a time, right? And you have to figure out if that letter well, or I shouldn't say a letter, if that character, right? Let's say you have a pointer, right? The pointer is a number, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, da, 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 da. So you're going to go from 0 to the length of this sentence. That's the loop, right? You have to loop from 0 to the length of this sentence. And then you pick out that letter at the current position. And then you find out if it is a letter or not, right? If it is a letter, you count it. You have to have a counter for this. You have a counter for this. You have to have a counter for this. You have to have a counter for this. Right? But let me see. The first one. How do you do the first one? What's the easiest way to do the first one? First count. You can actually do these separately, right? You can do them in 4, 5 different loops, but you can also do them in one loop, but then inside the loop, you work on each problem, right? So the first one, for example, number of different letters. You don't want to, well, you can remember what letter you have, right? The way to do that is to use a set. If anybody can tell me what the concept of a set is? Okay, a set in Python, you create a set with something like this, or this is a variable, right? I'm going to make it a set. Okay, right now this is an empty set, right? There's nothing in there. Okay, now I can say I want to add something into it. Right? I'll add a letter A. Okay. Now what do you think has a letter A, right? Not quite. Let me continue, right? Let's say if I now add a B. It has an A and a B, right? In the set. If I add a B again, what do you think there is in there? Does it have 1 B or 2 B's? It has only 1 B, right? That's a set. But let's say if I do a list, right? Right, exactly. That's the difference. So list, right now it's an empty list, right? So if I add an A in there, I can add. It's actually append, right? So this has an A in there. And if I append a B, now it has A and B, right? And if I do a B again, it has A and 2 B's, right? That's a list. So whatever you append to it on it, it'll just add on to it. But a set will not have duplicates. Okay, that's a set. So we can use a set to count letters, right? So if I just, I convert the letter to lowercase and I add it to a set, I can just go on, right? Continue through the whole string, and then at the end, I'm just going to count how many items are in the set. You can just do length the set. Right. I can add however many items into it. It'll give me the the number of unique items in there. Right. That would be a way to count. I don't know. Then I don't have to know exactly what. I just need to examine if the current character is a letter or not, right? If I convert the current character to lowercase, and then I can just compare it to quote A, right? If I do this, right? XC equals this set, or no, not this set. If I say X string is whatever, right? Whatever is in that string, right? I can say XC equals string, pick a number 5, right? So X string, right? From position 5, I'll just pick the letter 5, right? Or we can do this for I in, or just say XC, right? I can just go use this for statement to get each letter. For example, print, right? This will just give me, print a list of all the characters in that string. Right. This is a way to loop through that string or sentence, right? So you can get at each letter. Each character in that string, right? The string could be, letter, could be something else, right? And then when you have this, right? Let me see. I'll say if I can say XC1. I'm just making things up here. XC dot lower. Right, I'm turning it into lowercase. Then I can just say XC1 is greater or equal to A, and XC1 less than or equal to Z, right? This is a way to find out if this is a letter or not, right? And if this is a letter, now I'm going to print it out, for example. Right? This get rid of all those space or non-letter characters, right? So this is a way for you to figure out if it's a letter, right? And if you need to find out uppercase, then you make this if statement uppercase A and uppercase B, right? This is because all the letters or all the letters are sequential, right? in a sequence of characters, right? in the alphabet. In the computer, what is the character set? Okay, I know it's a little confusing, but just that all these letters are they're in the computer next to each other, if that makes sense, right? A next is B, the next one is C, and the next one is D. Right? So you can do this kind of range comparison. Right? So in this A to Z range, that all these would be lowercase letters, right? And if we don't do the conversion, right, then XC could have uppercase letters, right? So for the count of uppercase letters, you just use XC to see if it's in the capital A and capital Z range, right? So yeah, and now I guess the most difficult part in that problem is that how to to figure out words, right? So now you need to find out the current position is a non-letter character, right? So if you hit a space, then anything between your current position and the last whatever position, you have to remember some of these positions, right? That's one thing. So so if you want to find out a word, let's say you start with 0, right? 0 position, and once you go to 1, 0, 1, 2, 3, get to the 3rd position, and you find out that there's a non-letter there, right? It's a space there. Then anything between your last position and this is a word, right? So between 0 and 3, there's a word. You have a word of length 3 there, right? And now the next word would be the next position, right? From 4, 5, 6, 7, 8, 9. So between 4 and 9, it's another word, right? Of length 5. Yeah. Yes, you can use something to break it apart, right? But if you want to do that, that would be an advanced subject that you can learn. You can use string manipulation functions to break this apart into words, and then you just, you get a list of words, right? You get a list of words from this whole sentence, and then you just compute the length of each word. You can do that, right? But what I'm saying is, by looping through this sentence, you could actually, just by remembering these positions, right? Just, as you move along, you can find out the beginning of a word and end of a word of each word. And then you just need to remember which one is the longest, right? And what's the start and end of that particular word. Oh, you do have to have a list to do that, because it says, right, if there's a tie, and if you have 3 words that are the same length, right, that are the longest, then you have to remember all of them, right? So yeah, that might be a little complicated, but I'm just saying it can be done. The other way is, like you say, break it apart somehow, right? By these, yeah, you can Google that. You can figure out how you can break up a sentence, right, at these markers, right? That basically each and every one that is a non-letter character, you want to use that as a delimiter, right? And also, let's say you could have a double space somewhere, right? You would have to, you have to account for all those kind of conditions, right? So you get a list of words, and then you can iterate through that list, loop through that list of words and find out the length. Right. But then again, you still need to remember what's the longest. Right? And then you need to print out all the longest words. Right. All these characters are not, only letters are counted as words, right? So that's the homework for today. We only have 5 more minutes, so ask any questions. Any questions? What else are there? Oh, most frequent letters. Okay. How do you do that? Remember that with that Python does have a concept called a dictionary or a map. What that is you can use, right? This is an empty map, an empty dict. So if I do, it'll just say, give me an empty thing, right? But what I can do is I can use a letter as index. Okay. Now, if you do, then it'll give you a map of this thing mapped to that, right? I'm using this map to map letter to count, letter to integer, letter to count, right? So if I have another XA, I can just say, count. If I have another A, right, I'll just do that, right? So next time I print this, it'll give me 2 for the A, right? This is how we can do counting of all the letters, right? Right. And then what you do is at the end of the program, you just sort this map, right? You can sort this and get the top count, right? Or counts, could be more than one, right? So what you do is you in this map, you can just do xc equals that x string, for example, 9, right? I'll just pick any letter from that string. When I loop through that string, right, I can pick out the letter, and then I can say xm that letter, right? I can just do that. Even if that thing originally did not exist, I can do this. Oh, I cannot. Okay, so I cannot. That means you would have to. What you need to do is this. Let me see if I can do this. Right, this is another way to do this. Oh, xc in xm. That means I'm doing a test to see if that letter is already in the map, right? If it is, then I'm going to do xm plus 1, right? Otherwise, I'm just going to give it 1. No, hold on. It's actually, sorry, I'm mixing up different languages here. So if yeah, I think that's how it works. No. Oh, I forgot. But anyway, then I can just do this. Let's say if, let me see, just try XC in XM. Oh, okay. So I can do this, right? If XC in XM, then XM right, else XM. Oh, have to do this. Still not. Still not. I guess I'll have to put it into different lines.
Yeah.
Right, XM else XM XC. Right. So now you can see where that, oh yeah, it's an I, right? So basically that's how you would do that, um, counting most frequent letters. Right? So, okay, we're out of time. Any questions? Yeah. Sorry, what?
Kind of be silly, so, yeah.
Okay. You can find the problem in, here's how you find the problem, right? You go to this website, and then here, getting started, divisions? No, sorry. Student, oh, study material, sorry. Study material, junior division, and then this, I think this one, the second one. Okay, that's the problem. All right. Good luck.